Let's talk about doing a multi-step calculation that involves measurements. Now, the uncertainty in your measurements, your weakest link especially, is going to propagate into your final result. The longer the calculation is, the more that's going to happen, and it can happen to the extent that your final result is completely unreliable. This has led to a lot of engineering disasters whenever there's a lot of round-off error in a calculation. One notorious example of that was in 1992 in the first Gulf War. There was the Patriot anti-missile battery protecting soldiers in the Persian Gulf. And the targeting computer stored times and velocities in a way that it rounded them off between calculations. So as the targeting computer ran longer and longer, round-off error accumulated in the final result. When a Scud missile did come in, it was pointing the anti-missile battery in the complete wrong direction, and the missile came in and killed 28 soldiers. So this can be a serious thing, and the moral of the story there is never to round off intermediate results. So the only time you ever round anything off is when you're going to show it to another human being. Rounding off is for reporting a number. It's not really something that you want to include in your calculation. So I would keep all of my intermediate results out to full precision, out to as many digits as my calculator gave me. And the only time I'd round them off is when I was going to show them to someone else. Let's look at a simpler example than the one I just gave you. Suppose I'm taking the difference between two numbers. All right, how do we do that from the last video? Well, we've got 2 decimal places here and 2 decimal places here, so our answer has to have 2 decimal places as well, and it does. And how many significant figures does it have? It only has 1 significant figure. It has 2 decimal places. Now, what if we had said, okay, let's round off the 2 numbers that we're subtracting before we do the calculation? In other words, let's round off intermediate results and see what happens. If I round off the 29.35 to 29.4, I'm rounding it down to 3 figures. And if I round the 29.34 off to 29.3, and then I take the difference, I get 0.1 milliliters. That's the difference. Now, do you see the difference? And the difference is, this difference is 10 times the size of that one, and it's just because I rounded off intermediate results. So that's why you should never do that. So let's look at a specific example of doing a multi-step calculation that has a couple of little subtleties in it. Suppose I want to add these 2 numbers, and then I want to divide them by 290.0. So I'm dividing a mass by a volume here. I guess I'm getting a density. So what you do when you have an addition and a division in a calculation is do them one at a time. Which one should you do first? Well, when you've got parentheses in a calculation, they mean do this first. So anything between the parentheses you're going to do first. So that's this. I'm going to do the addition first. Now, how do I track significant figures through this? It's a little different from the example we had in the last video, where we're looking at the number of decimal places to find the weak link. Well, we're still looking at decimal places here, but it's in a slightly different form because these are big numbers rather than small numbers. What do I mean? Well, where's the estimated digit? Here it's in the thousands place. And here the estimated digit is in the hundreds place. So which one's the weak link? Well, knowing something only to the nearest 1,000 is worse than knowing something to the nearest 100. So this is the weak link. So that's how you're going to handle finding the weak link with large numbers. Look for the one that is the most uncertain. All right, so my uncertainty in my result when I add these 2 up is going to be uncertain in the thousands place. In other words, the thousands place is going to be the last digit that I report. All right, so the last digit that I retain. So if I add those 2 up, I get 293,300. And I'm going to underline or gray out the digits I know aren't going to stay, because I've got to keep 3 digits up to the thousands place in further calculations. But I don't want to just cut that off or round it off, because that would be rounding off an intermediate result, which is bad. All right, now that I have added those two together, I can do the next operation, which is the division. I can divide it by this. Now this has 3 significant digits, and this has 4 significant digits. So which one's the weak link? This one's going to be the weak link. And your final result is only going to have 3 significant digits in it then. So when I punch this into my calculator here, I get a number that looks like this, and I am going to cut it so that I have only 3 figures. I'm going to put the cut here, and I'm going to round off. Now, here's where the cut is. That's less than a 5, so I'm going to round down. So I'm going to end up with 1010 kilograms per cubic meter. How about those units? Did you see where I got those from? When you add these two together, you're going to get kilograms. And then when you divide, you're going to divide the units. So I'm going to divide kilograms by cubic meters. And I'm going to get kilograms divided by cubic meters as my units in the end. Let's do one more example. Suppose I want to take a difference between 2 masses and divide it by a difference between 2 volumes. So once again, I'm getting a density because it's a mass over a volume. All right, if I'm doing subtraction, I need to use the rule that says you look for the decimal places that you've got. And the weakest link will have the fewest decimal places. Well, now this one, it goes out to the thousandths place. Is 3 decimal places to the right of the decimal point. And this one goes out to the 10,000ths place. It has 4 digits to the right of the decimal point. So which one's the weakest link? This one, because knowing something to the nearest thousandth isn't as good as knowing something to the nearest 10,000th. In other words, when I subtract these two numbers, I am only going to keep the result out to the thousandths place. So I do that subtraction. I get 2.9220, but I'm only going to keep it out to the thousandths place. I'm not going to round anything off yet. Remember, that would be rounding off an intermediate result. So the parentheses said do that, but there's another set of parentheses here, and they say do this next. So you do things in parentheses first. The innermost parentheses get done first. You work to the outermost parentheses. When all the parentheses are gone, then you're ready to do other things. All right, so 42 minus 1 is 41. How many digits? Well, this is a subtraction, and I only know this to the nearest milliliter. I know this one to the nearest milliliter apparently too. They don't tell me otherwise. So the answer is going to be uncertain to the nearest milliliter as well. So this one has 2 significant digits. Now I'm ready to do the division here. I'm going to divide this by this. And when I punch that into my calculator, I get this big long number, and I want to round it off. But this has 2 significant digits, and this has 4 significant digits, and I'm doing a division, so you take the weak link in that second calculation as this one, the one with the fewest significant digits. And that means I'm going to round my answer off to 2 significant digits. Now, some people will say round it off to 0.07. That would be wrong, right? Because that 0 there is not a significant digit, actually. We're keeping it in the calculation because it tells us what size our final result is. But it's not, if I was counting significant digits and I wanted this to have 2 significant digits, the leading zeros don't count. So it's going to be 0.071 if I want to get 2 significant digits, not 0.07, which a lot of people will say. So I'll take this number off my calculator, round it off so it's 2 significant figures, and report it as 0.071 grams per milliliter. And you can see again where I got the units. When I subtract these two, I still have grams. When I subtract these two, I still have milliliters. Grams divided by milliliters will be my final units.